Hello everyone, welcome back to the Academy. I'm Dr. Husuli, and in today's episode we're gonna take a look at an advanced case in GaBi software. We will start by looking at LCA framework including goal and scope definition and also system boundaries, and then later on we will take this case to GaBi software and start to do the lifecycle assessment on this case. Without further ado, let's start this tutorial.
Perfect. So before going to the software, as ISO standard recommend, we need to define our system boundaries as well as the goal and scope definition of our case. For any advanced case, we need to have these informations. And in our case, in this advanced course, we're going to have an asphalt production site, which is going to be responsible for providing the mixture. And this mixture will be moved to our site, which we are looking to make an asphalt road. And after the paving the road, then this road is going to be served for a specific period of time. And at the end, it's going to end up in a landfilling site. So this case is slightly different from our intermediate case. If you are new to the course or new to the concept of lifecycle assessment, I would suggest you to start watching the intermediate level video and then come back to this one and continue with the case. So we have defined now our system boundaries, but still lots of details is missing from this case. So we need to define those as well. One of the important steps in lifecycle assessment is understanding of the case. So in our example, what we are looking for is a road patch size. So in this case, we are considering to have a 10-meter long road, an asphalt road, with a width of 2.1 meter and a depth of 80 millimeter or 0.08 meter. Using these values, we are able to find the volume that this asphalt needed, which is 1.68 meter cube. Remember that in life cycle assessment, we either working with mass per kilos or per tons and the energy, megajoule or any values. So what we are missing here basically is the mass of this asphalt that it needs to be produced in the asphalt site. Using the average density value for the asphalt, you could find it from the literatures or it could be given to you by the producer. In this case, it's 2.4 tons per cubic meter, which is 2,400 kilos per meter cube. Using this density value, now we are able to define our mass, which is 4.03 tons of the asphalt. It's most likely that this hot mixture asphalt plant would produce asphalt in minimum of 1 ton batches. Therefore, the purchase quantity would be 4 tons for this case. So now we know how much asphalt we need for this case. Moving forward and going to the details, now I have to define my inputs to my asphalt production site, the hot mixture I need for producing the asphalt. One of the points that I'm looking for in advanced course is to developing the skill to identify the case and dealing with the different aspects of the scenario. So in our case, let's consider as a normal asphalt, usually this asphalt has 3 components. One is a coarse aggregate, which is the gravel. Usually it has 40 to 70% of the total asphalt mixture. And the other one is a fine aggregate, which is sand, between 30 to 60%. And the third component, which is the asphalt cement, is bitumen, which is 4 to 7%. So this is a normal configuration. And you have also a little bit of mineral fillers and additives as well. So this is a general idea. However, in my case, now what I'm trying to do is to define my system boundaries and my inputs to the system. So in my case, as I mentioned before, I'm dealing with 4 tons of asphalt mixture, which is around 4,000 kilos. And I'm not going to consider the mineral fillers or additives in this case. So I'm going to have only a gravel, sand, and bitumen. So in my case, the gravel mixture is going to be 55% of the weight. 41% is going to be sand and bitumen is going to be just 4%. And if I do the mass from the 4,000 kilos with these percentages, I have 2,200 kilos of gravel, 1,640 kilos of sand, and 160 kilos of bitumen. So now I know my case. What I need to also define is usually this mixture needs to be heated up. And how I can get the numbers for this required heat, I can go and ask from the producer, or I can look for the articles to find these values. So different ways are here in order to be able to define the different aspect of the project. So from one of the literatures, I managed to find that the heat needed is 250 megajoule per tons for mixing these components in asphalt production or hot mixture asphalt plant. And what I'm considering as well in my case is that this heat is gonna be provided from the biomass in this asphalt production site. So this is my case. Now I need to go more in details in defining my life cycle assessment. Okay, I'm gonna consider this coarse aggregate and fine aggregate components will be produced. So I have a production of 2,200 kilos of gravel and 1,640 kilos of sand. These two will be produced, and using a 20-ton truck, Euro 3, it's going to be transported for 160 kilometers to the hot mix asphalt plant. Then in this plant, I'm going to consider I have a bitumen coming from the refinery, 160 kilos as an input to my asphalt production site. I have now 3 inputs as a mass and 1 input as energy, which is going to be the heat needing for the mixture. I've got the number from the article that this is an average of 253 megajoule per tons, and I'm also considering that heat's coming from the biomass. After providing the mixture in this plant, now the mixture needs to be moved to my production site, asphalt paving site basically. I'm gonna use a 20-ton truck, this time a Euro 5 for 80 kilometers, and it's gonna be fueled by diesel. On this production site, on this asphalt paving site, what is needed is a heat road roller. Usually the energy, the heat input to this site is going to be around 150 megajoule per tons. I got the number from an article. So now after paving the road and providing an asphalt road, it's going to serve for a specific period of time, and it's going to end up in landfill, which is going to be the last phase of my case. So this is a general idea of my case. Now I know that how it's going to be my life cycle assessment scenario. Before moving to GaBi software, I would like to discuss about inputs to the system. So in my case, coarse aggregate as gravel and fine aggregate as sand. So all of this information and graph that you see now, I've got them from the software library. I'll show you later how you can access those information. But what I do find from the library of the software is the technical purpose of the product is a standard mineral product used as a natural aggregates in construction industry according to the applied technology. So basically these are standard mineral products, and the numbers that you can see 0.2, 2.32 is the size of them. So what this graph shows basically is I have a mining, environmental impact assessment of the mining, environmental impact assessment of the transport inside, environmental impact of washing, pre-classification, crushing, and classification. So all of the environmental impact of these steps is considered in this block in the software. Also, for example, I have diesel as an input to the system, I have water, I have diesel again for the crushing, and also, for example, lubricants and etc. So this production, this technical purpose of the production that you can see for the cars and fine aggregates actually includes all of these environmental assessments in terms of the transport, washing, and pre-classification during the production of these aggregates. The next one that I have as an input to my system is bitumen. So in bitumen, which is the asphalt cement, I've considered that this bitumen production site is very close to my asphalt mixing site. So I'm not gonna make any transport for this production. So what I get from the library information is that the technical purpose of the product is a supply of 1 kilos of bitumen for the construction industry and other consumers. So it's provide me 1 kilos of bitumen, this block, in the GaBi software, and the graph basically shows me this refining model in GaBi. Basically, you have an inputs of the crude oil, natural gas, electricity to the system, water, and then you have a products, emission, wastewater. So what it shows basically shows that in this block, it's the simple block, GaBi software considered all the environmental aspect and environmental impact of refining model of the bitumen or any product, refinery product. So in this case, the dataset considers the whole supply chain from crude oil exploration to installation, production, and also transport to refining operation. Background system is also considered. For example, as you can see, it's EU28, and the electricity is modeled according to the country-specific situation. We also have, for example, the transport, and all relevant and non-transport processes are included. Coming back to other two inputs to our system, coarse and fine aggregates, the life cycle assessment of sand and gravel covers the coring of a stone and its preparation, as you can see on the graph. And the preparation of the raw minerals begins with the washing of the stone grains that have been extracted from the mining site. By adding clean water, which means washing here, the raw minerals is released from other substances such as loam, clay, or wood or coal or any other minerals and substances that we don't need it in various washing stage. This also is considered here, and the assessment also includes the life cycle from energy generation and raw material supply to finished product on factory gate. In this scenario, the infrastructure and production of the manufacturing facilities is not considered, and the transports gate to building site are not part of the system and have not been considered in this case. In this scenario, the electricity is modeled according to EU28 specifications, and all relevant and non-transport processes are included. Ocean going and inland ship transport, as well as rail, truck, and pipeline transport of bulk material are also considered in this scenario. Start to work with GaBi software and start to do our LCA modeling in this software. One of the points that I'm trying to do in this advanced course is first try to use the educational database, which obviously is going to have a lots of limitation, but what we are trying to do in advanced case is being able to have our custom modules and custom lifecycle assessment, even considering a limited database such as educational database. So similar to previous tutorial, if you don't know how to activate the database, please again refer to our intermediate level course. So you're going to select your database and then you're going to click open. It's going to take few seconds or a minute to load the database for you, and then the GaBi software will be ready for you to start to do your modeling. Okay, what we need to do now, we need to start by defining our plan. Going to the plan tab and then right click new. I'm going to define my case. So let's put a name for this one. So I'm calling this one Asphalt AU as a Kingston unit. Then I need to save this. Once I saved it, it's going to be activated here. The next step we need to do, we need to start adding our processes inputs basically to the system. One of the ways to do that is going through the search function here and then looking for our components. You remember from the slides that as an input of the material, we need gravel, we need sand, and we need bitumen. So we're going to try to add all of them here. I'm going to look for gravel here, and then I'm going to find the production mix at plant. I'm going to drag and drop it to my default plant, and I'm so going to look for sand. Again, I managed to find this one, production mix at plant. I'm going to drag and drop it to my plant over here. Remember that you can always right click on that and then go to the database setting. What is very good about the database settings, if you go to documentation tab, we will be able to see all the details that I've discussed with you before in terms of the details of this process. For example, you can say the foreground systems, background system details, and then even the graph that we have discussed together, where these information are coming from, data sources for this used for these data sets, where those information are coming from, and also the reviewers. All the information are presented here. Same for the sand. If I go to the database setting, I should be able to see all of those details in documentation tab as well. What I need to do now, I need to now double click on that or go to the local setting. And what I'm going to do now, I'm going to add a mass of the material that I'm dealing with. So remember from the slides that for the gravel, we defined that it's going to be for 4 tons of asphalt, we need 2,200 kilos of this material. I'm going to put this one and then click OK. Then I'm going to go to the sand again by double click on that, or going to the local settings, and I'm going to add the values here. Remember that for the 4 tons of asphalt that is considered for my case, I need 1,640 kilos of sand. And then click OK, and I have basically these 2 inputs ready for my asphalt process. Now I have my 2 inputs. What I need to add is basically transporting them from production site to the hot mix asphalt plant. For this one, as you may remember, I need 20-ton truck, Euro 3, and it needs to be transported for 160 kilometers. I'm going to look for truck with mention the specification. Going through the search tab, I'm going to look for truck, and I need a Euro 3, which I have here, 20 to 26 tons, looks okay. As I need 2 of these, so I'm going to drag and drop 2 of these here. And what I need to do now, I'm going to double click on the first one. And as you may remember, for gravel, this one is for gravel, and the gravel weight was 2,200 kilos. I'm going to click OK. For the sand, it was 1,640 kilos was for the sand. So these are my cargoes basically. And another input that these 2 trucks are in demand is diesel, and I have to look for the diesel again. Going through the search tab, I'm gonna look for diesel, and I'll pick the EU28 diesel mix at refinery. I need 2 of these, so I drag and dropping 2 of these over here. So the remaining part is I need to go to database setting, and what I need to also look, sorry, not database setting, needs to be the local setting. So on here, as you remember, distance needs to be 160 kilometers. I'm gonna put 160 here. So I will consider, in this case, be a bit more complex, have a more complex case. I can consider, so these values is basically showing the share in motorway, in rural areas, in urban areas. So I can basically work on this is 70% basically. I will put, let's say, less here and more in this area. Okay, a bit diverse from what we were looking for. You can also here check the share value. It needs to be equal to 1 or 100%. I'm going to click OK. Going to the next one, the distance is same. I'm going to put 160 kilometers as we have described. But in this case, let's say this truck takes a different route. So I'll put more highway and less rural areas. This needs to be equal to 1 and make sure that these values are equal to 1, and I'm going to click OK. Now I have all the components that I need to move my gravel and sand from the production to the site. Now coming back to connecting the components together. So I can move them, adjust them a little bit more, like this. Maybe move a little bit here. So I need to connect the gravel to my truck, and it's gonna ask gravel, and I'm just gonna select gravel on source, and then a sink is gonna be cargo. On the sand side as well, from the right hand side, by holding the left key on the mouse, I'm gonna connect it to my truck. Again, I'm gonna select the sand from the source, and the sink gonna be a cargo. What I could do, I also could go to the view and then show the flow quantities. And now it shows basically the amount of the materials that is transported from the production site by this truck. So please pay attention also to thickness of these arrows. So thicker means that it has more weight or mass of that. The next part is going to be the connecting the diesel's inputs. So I'm going to connect my diesel, and I'm going to connect my diesel as well. So please take a note to the amount of the diesel is needed for these two trucks for this 160 kilometers. You see that for this one it's around 8.5 kilos. For this one is 6.4 kilos, and the difference basically comes from the weight of the material and also the formation, the share of the motorway and rural areas and urban areas that we have defined. This is now almost completed, and now what we need to do, we need to move them to our mixing plant. Okay, going to hot mix asphalt plant, because this plant doesn't exist in the GaBi software. So what we need to do, we need to create this asphalt production site. So what we're gonna do, I'm gonna right click on any blank space, go into the new processes, and processes, and then production. Then I'm gonna click OK, and this window will pop up. For now, I'm just gonna call this as hot mix asphalt plant. Yeah, makes sense. And then I'm gonna save this one. I'm gonna close this window for now and expand this a little bit. Okay. One of the other important inputs to this mixture was bitumen. So I'm gonna look for the bitumen here as well. Remember, the only difference was that we are not now transporting the bitumen, and we are considering that bitumen is produced at site. There's a refinery very close to asphalt production site. So I'm gonna look for bitumen. Bitumen, look for it, and I can select the same specification EU28 bitumen at refinery. I'm gonna move this here, and what I need to do now, I'm gonna need to basically move transported material input to the hot mix asphalt plant, and also bitumen to the plant. Another point was also it was mass, and then we needed some heat as well. Remember the heat from the biomass, 253 megajoule per tons. I'm gonna look for heat this time using the search menu, search function here, look for heat. And this time it's important for me to look for heat from biomass. So I'm gonna select, let's say, heat EU28, heat from wood pellets, which considered as a biomass for me. I'm gonna drag and drop it here. Now I have all the inputs that I needed for my hot mix asphalt plant. Remember that we had all of these on this slide as well. So as you can see here, now we have defined the gravel production, sand production. We moved them, we transported them with the tons truck Euro 3 for 160 kilometers to the hot mix asphalt plant. We had bitumen at refinery for 160 kilos. We haven't defined the weight on this one yet. And then we had also heat from the biomass for 253 megajoule per tons that we haven't defined this value as well. We also created our hot mix asphalt plant too. Okay, let's add details here as well. So for bitumen, I double click on that. I can put the amount of the bitumen that I have defined based on 4 tons of asphalt, which was 160 kilos. I'm going to click OK. And also I have defined the heat based on an article, how much it is needed for this system. So it's going to be 253 megajoule per tons. So if I have to define, so because it's now we are dealing with 4 tons, so 250 multiplied by 4 is gonna be 1012 megajoule for our case. And I'm gonna click OK here as well. So what I need to do now, I need to connect these elements to my hot mix asphalt plant. The only issue here is that if I go to local settings here, there is no inputs and outputs to the system. So how can I define it? I go to the database setting. I have this one. So remember, you can do different ways, but what I do suggest is you have this window open here. You go to your input. So remember that I had the gravel. I go to the outputs. I'm just gonna copy the details, which is easier for me. Now I can come to the inputs here, double click on that and add this gravel as an input. The next one is a sand. Again, I'm repeating. So I could come back to my plant, going to the sand block, and then open this one by double clicking on that, and then copy the details of the output flows. I'm gonna close this. I'm gonna come back to my hot mix asphalt plant. As an input, I'm gonna add this one by pasting the details. So I have 2 inputs. The other input was bitumen. I'm gonna again double click on bitumen, going to the output flows, copy the details, and then I'm gonna come back to the inputs, right click, and then it's the bitumen. Okay. And the last one was the heat input that I was needed in the hot mix asphalt plant. I'm gonna double click on heat, going to the output flows, copy this one, coming back to my hot mix asphalt plant, right click, and then paste this. All of them are mass, the only one is heat. So remember the values, yes. So for the gravel, it was 2,200 kilos. For the sand, it was 1,640 kilos. For the bitumen, it was 160 kilo. And the energy was 253 megajoule per tons. We're dealing with 4 tons, so it's gonna be 1,012 megajoule. And what I can do, then I can save this one, and it's gonna be saved here. What I need to do now, I only need to connect these values to my hot mix asphalt plant. As you can see, while I'm connecting, I can see the values that's connecting. The only thing here is that I have to define the source and the sink as heat. And the reason that it shows 0, because the heat is not defined by mass, it's defined by the energy input. If I want to see that one too, I can go to the selection KU asphalt on the top right hand side, and then going to the quantity, I will change this one from mass to energy, and it then shows the energy inputs. Remember, you have also some energies because it's been considered that bitumen has some energy at the point of the refinery as well. Coming back to the mass, now I have my system as intended to be designed. Now I need to continue by moving this hot mix asphalt plant by a cargo, which is going to be the 20 tons Euro 5 truck to the production site. Okay, what I need to do now, I have a hot mix asphalt plant that has all the inputs, but it's missing the output. For the output, because the product is asphalt produced in my plant, it doesn't exist in the library, so I need to create it. What I need to do, I need to come back to DB Manager and GaBi software, going to the flows, and then I have to create that one, basically. So I'm gonna go to valuable substances, materials, and then minerals. Okay, in minerals, anywhere, I just can right click on that, and then I will create a mineral, a new one, basically. In this window, what I need to do, basically, I just need to write, because it's a mass, so I need to write, let's say, KU mixed asphalt, yeah? And then I'm gonna save it. Now I have this one as a valuable substance in my flows. Using this window manager, I'm gonna come back to my original plan. And now what I need to do basically now is to define the further steps. What I need to move this produced asphalt to the road, to the construction site, I need a truck. And based on the details that we have discussed, I need to look for a truck, this time 20 tons, but with the Euro 5 and for 80 kilometers. I'm gonna look for a truck, and this time I'm looking for a Euro 5, and to make it a little bit different. So scrolling down, I should be able to find Euro 5. Yes, this one. And looking for something that it could do the work for us. Well, let's say Euro 5 truck 20 to 26. What I need to do, similar to the previous ones, I need to just drag and drop it. Remember, this truck also needs a diesel input, so I'm going to look for a diesel, EU28 diesel mix at refinery, drag and drop it here. Okay. Try to organize it a little bit more. Okay, so what I have now is a truck, but it doesn't have any inputs, and also I have also a hot mix asphalt. I'm gonna go to the local setting, and sorry, I'm gonna go to database setting here, and I need to try to define my output flows as well. I can write as a KU asphalt mix. Okay, and remember the amount, it was 4 tons, so I'm going to just put 4,000 kilos as an output. I'm going to save this one. Now I have basically what I have here in this hot mix asphalt plant. I have a factory that actually is responsible to mixing gravel, sand, and bitumen using heat to produce a mixed asphalt for me. And this one is going to be then transferred to the road, to the construction site. Okay, what else needs to be done? I need to also define the inputs here as well, as you remember. If I go to database setting, now I have, for example, the cargo, the diesel, etc., etc. I need to connect this one to the truck. KU mix cargo, it's going to be defined. So you see now, now I have a 4 tons input to my truck. And what else needs to be done is that I need to add the diesel mix from the refinery as well. The value that shows here 9 kilos, it depends on the weight and the distance, but remember, we haven't worked on the distance yet. So by double clicking on the cargo, I need to now define the distance. Remember, the distance was 80 kilometers, okay? Put 80 and then click OK, and now it's reduced a little bit. Okay, what we have done so far, we have basically modeled everything up to this point, up to, let's say, this is the gate of the hot mix asphalt plant, and now we are moving or produced asphalt by using a truck to our asphalt paving site. So in the asphalt paving site, first we need to create this construction plan in our GaBi, and also we need to provide heat road roller to this site. Couple of ways that you can add this machinery, because remember, in life cycle assessment we don't care about the machinery, we care about the energy and the mass concept over here and environmental impact of those elements. So a way to put heat road roller, two ways basically. One way is to look for the amount of the normal and average heat needed. In this case we look for it and it's about 115 megajoule per tons, and then we put it as a heat input. The other way is that look for the, for example, the diesel consumption of these road roller machines, and then look for the heat capacity or heat content of these diesel, and then transfer it to the amount of the energy based on those factors. But in our case, it's a simpler way. We have 115 megajoule per tons because of heat road roller that's going to be needed in the site. So we're going to come back now to the GaBi and trying to model the asphalt paving site. Perfect. Coming back to GaBi software now, what we need to do, we need to model our asphalt paving site. And for this one, because we don't have it available in the GaBi library, we need to create it ourselves. Similar to what we did with the hot mix asphalt plant, we're gonna right click on any blank space and then we're gonna create a new process, and it's gonna be the production. And because we're producing the road basically in a simple word, and we're gonna name this as asphalt paving site. Yes, and then we're gonna save this one. Perfect. So what we need to do now, for now, I'm just gonna go to close this one and I'm gonna expand this similar to the previous case as well. What I need to do now, coming back to the slides, you remember that we had a heat from road roller equal to the 115 megajoule per ton. So I need to have a heat input to this one as well. I'm gonna use the search function here and gonna look for a heat input. What I'm gonna describe here, so look, because this is a student library, the heat units that we have here are very, very limited. So usually the heat used in this kind of machineries, like heat road roller machineries, they use heavy fuel oils like diesel, etc. But because we don't have it here, we're gonna simplify our case and we're gonna consider it only the heat from light fuel oils. It's not gonna be 100% accurate, but this is the reason I'm trying to work with the student library to show you that even we don't have all the information, all the libraries, comprehensive library from professional library of the GaBi, it would be possible to model with some scale of the accuracy. Now, the only issue here is that my asphalt paving site doesn't have any input or outputs. So how can I solve this? I can look at database setting, and in database settings you should have flows. Similar to what we did with the hot mix asphalt, we need to have some materials as an input. So output is the KU mixed asphalt, and we need to provide it here in the database setting as a flow, because this is the asphalt that trucks will be transported from hot mix asphalt plant to our asphalt paving site. Another input that we needed was the heat, basically. So what I'm going to do, I'm going to double click on that, take the output flow, which is the heat as a thermal energy, and just going to add it here. So how much of those asphalt is going to be transported? All of it. So it's going to be 4 tons, 4,000 kilos. And in terms of the energy, remember what we have described it before, 115 megajoule per tons. So if it's 115 megajoule per tons. We're going to multiply it by 4, and it's going to be 460 megajoule as an input to the system. We're going to save this one, and now we should have everything that we need for this one. What we're going to do, we're going to hold the left key on the mouse, connect to this one. You're going to see that the 4 tons of asphalt, produced asphalt in hot mix asphalt plant, it's going to be transported by your Euro 5 truck, and it's going to be arrived at asphalt paving site. On asphalt paving site, we need a road roller, heat road roller device machine, which is going to be input some heat for us. I can take a look at the amount of the heat that I have defined here as well. I will click on any blank space, and then from here I'm gonna select energy, and it shows 460 megajoule of energy that we have defined already. Coming back to the mass, now we're gonna have it as a mass. So the final step is the basically landfilling steps of this asphalt production. Now we're gonna model that one, and then your life cycle assessment should be completed. What we need to do now, we need to now define an end of life scenario for our case over here. So in our case, as we discussed before, the asphalt is gonna have an end of life scenario in landfill. So what I'm gonna do, I'm gonna use the search function over here and look for landfill among all the processes that we have. So landfill, and it kind of shows you different landfilling processes, and most of them depends on the type of the waste that you have. So it could be paper waste on landfill, textiles on landfill. So most of the cases you define them based on your material. So in our case, because it's asphalt, and asphalt usually considered as inert matter like glass, we're going to use inert matter glass on landfill, and we're going to drag and drop it to our program. We can consider that the landfill site is very, very close to asphalt paving site. So, or we can also consider that that will be needed to moved by a truck. Let's consider having a truck on this case as well. So I'm planning to use a similar kind of a truck over here as well. Truck Euro 5, 20 to 26 tons. So 6 tons, Euro 5. What I'm going to change here, I'm going to just open this block, and it's going to modify the distance. I'm going to reduce it to maybe to 8 kilometers. Yeah. I'm looking for a very small environmental impact on this. I'm going to click OK. Similar to previous one, it needs also a diesel. So I'm going to add a diesel input to this truck as well. So diesel and biodiesel mix at refinery. That's perfect. However, if I go to the database setting over here, you see that it's not been defined yet. So what I need to do, I need to double click on this and put a mass of 4 tons. Imagine it's been now removed from the road and needs to be moved to the landfill. So what I'm gonna do, I'm just gonna connect these two together. Okay, because we don't have an output here, so we need to define that output here as well. So I'm gonna define this as well too over here. In order to do that, we need to define the material similar, the flow basically for the output flow for this one, because we don't have a used asphalt here as well. So I'm going to close this, coming back to the main DP manager, following the same route. So flows, materials, minerals, and then gonna define a new flow. And the new flow, I'm gonna name it as, let's say, end of life asphalt underline KU as well. And I'm just gonna save this one. Now I have basically deconstructed Asphalt as well in my library. I'm gonna come back to my plan, and what I'm gonna do, I'm gonna go to the local setting over here. You see that I don't have any output. So coming back to the database setting, and I need to add a flow over here. So what was the name? It was end of life KU Asphalt. We don't have any waste on this. We're going to remove everything that we have already paved on the road, so 4,000 kilos as well. And I'm going to save too. So now I have a material over here as an output. I can connect it to my truck, end of life asphalt, cargo, then connect it. What I need to also connect is to connect diesel to my truck. So it serves a very few kilos of diesel because the distance was shorter than in comparison to the previous one. And finally, what I need to do now I need to define the output for this landfilling site. So I can basically connect this one to this and end of life as well to the waste as here. So now I have my plan completed as I was planning to do with a different stage. Now I'm ready and prepared to run the simulation and figure out about the results. One important point to mention, as I've also mentioned in intermediate level of GaBi tutorial, is that we need to have one fixed process here as well. So as we were focused on production of hot mix asphalt plant, I can fix this one as my scaling factor per 4 tons of asphalt. Then I'm going to click OK. Now I have one fixed plan. As you remember, this red cross shows the fixed plan. And then I can start to calculate my results. So I must go here to result calculation, click on that. It might ask me for save the plan, and it takes a couple of seconds to give me the initial results. So these are the initial results that I've got from doing this simulation with this assumption. I'm going to talk about a little bit about the results as well. So if you want to see more details of these results, so this one is one of the most important one, is global warming potential over 100 years by Tracy, and it shows around 250 kilos of the CO2 from this production of this 4 tons of asphalt. You can go to results tab over here, and it shows you details in more information. What you need to do now, you need to click on these 3 dots over here. What I'm looking for, trying to look for more standard way of presenting the results. I'm gonna go to environmental quantities and then look for maybe something that it can help me better in terms of presenting the results. So I'm gonna go with the CML 2001 and then CML global warming potential over 100 years. Double click on that and it's gonna show me all the information that needs to be. What I can do later on, so all the info now here, it's transferred to the kilos of CO2 equivalent based on the global warming potential on the CML standard. So I can increase number of the rows, or I can keep it as one and then I can show you. So if you double click on each row, it's going to expand it based on the subcategories. So I have resources and also I have emission to air. If I double click on that, it's going to show me again inorganic emission to air and then organic emission to air. And if I double click on that, it's going to show me by, for example, in terms of the carbon dioxide or other factors over here. You can also go to the rows and increase it to maybe 6 rows, and it's going to show you based on the 6 subcategories. I'm going to keep it as 3 for now, so to show me just the most important, or even at least 2 as it was. And also I can double click on the Asphalt KU, and it's going to show me the sub plans on my general plan. So what's the proportion of the other other elements and values over here, basically. I can click on weak point analysis, and it's gonna highlight the most important areas in this simulation, and it's gonna highlight them in red. So it shows that the highest factors is basically related to the production of bitumen and other as well. What I can also do, I can look for the diagram as well. So it shows me basically the diagram. Or if I'm not completely happy with this, I can come back to the initial results, and it shows me basically all the values. So as you can see here, the total value, as I mentioned, is around 250 kilos of the CO2 equivalent. Then I have sub-processes. So 54.4 of these 250 is from bitumen and refinery. Then 44 kilos from the heat that we have used. Then 54.7 kilos of the CO2 equivalent from the landfilling the asphalt. And then around 27 kilos is from our truck, Euro 3 truck. From the Euro 5, it's 23, and the rest is 46 kilos of the CO2 equivalent. You have a variety of resources here to take a look and analyze the results based on that. Perfect. So we are almost right at the end of our advanced case tutorial. And what I'm planning to do maybe in the next videos is to look to the other function of the GaBi software. GaBi is a very powerful tool. So for instance, if I want to save this results, I can save this results. And a powerful tool is an analytic tool of GaBi. So with this tool, basically you can have scenario analysis, sensitivity analysis, and also Monte Carlo analysis, which basically in a simple word means that, for instance, I could remodel this plan based on the different scenarios that's happening inside my hot mix asphalt process. So if I go, for example, to local setting over here, you can see that I have some input flows and output flows, and I have also some parameters. By double clicking on the database setting at the moment, so I can expand this part in terms of the parameters, and I can add some parameters here. For example, I could have heat part A, part 1. I could also have, for example, heat part 2 as it is. And then also I can say, for example, these are based on megajoule, and this one is also based on megajoule. And what I could do, I could have them, let's add another one as, for example, heat total. Yes. So I can have, for example, different values here. I can have as a heat value of, let's say, I don't know, 500. And please note the changes that happens here in terms of the quantity, etc. And then I could have, for example, 601. And what it could happen basically is that you can define different scenarios, and those scenarios could be defined and happens during the life cycle assessment, and you can see different iteration of those results in terms of those parameters in terms of what you get from the results. You can even define them as a formula, so I can put here heat part 1 plus right click, insert parameter, local parameter, and part 2. If I click enter, it turns blue. And as you can see here, now I have a value basically equal to heat part 1 and heat part 2. Even I can make some changes over here as well. So, and it's going to affect also later, we can need to define here in terms of the factor. And these are more complex cases, and I will go through them maybe in another video, but plan for the future is that we're going to have a video. The next video will be focused on WindPro software, which is a software dedicated to designing the wind farms. Later on, we will have sets of tutorials on SEMA Pro software and other powerful tools for life cycle assessment. And then later, if I have time, I might come back to GaBi software and try to explain other powerful aspect of the software. We arrive at the end of our video today. I hope you have enjoyed the video and wish you the best. Until the next time.